Right. Good afternoon, everyone. I'm, like Prem said, very wonderful introduction. I'm Vijay. Today, I would like to present about how we can leverage observability for better DevOps, but specifically how we can use OpenTelemetry while we do that. Quick introduction about who I am before I proceed. I've been in the industry for close to 11 years, so let's say greater than 10. I run my own software consulting company. I used to work at one of these companies. You may have heard of them, ThoughtWorks, Nubank, and Postman. The vision of my company is to leverage all of this expertise and then democratize that to startups around the world, building large-scale software systems and teams. The agenda for this talk, what we'll go over very quickly, just to give you a lay of the land, is what is observability and why it is useful. Some of the pillars of observability, the what and why of OpenTelemetry or OTel. You'll notice that I used a little shorthand there called O11Y, much like Kubernetes. It's observability. We look at OTel architecture, kind of a generic architecture. You can go in on this subject quite deeply if you really want to, but I will be providing a high-level overview. Leading into that will be the architecture of the demo itself, and I'll try to do a hands-on demo here itself for you. Finally, given that we are in like a DevOps themed talk today, I will show you, or rather present a couple of cases of why observability can really help DevOps. Finally, we'll have some time for Q&A if you have any. Cool. So just a quick show of hands so I have an idea of where the room is. Have you all heard of observability? Awesome. So that's almost everybody. So observability, kind of more formally defined, is the ability to understand the state of a system by looking at its outputs. And the outputs in the parlance of observability are logs, metrics, and traces. So these signals or these outputs can come from application services like APIs, or they can come from infrastructure like Kubernetes, VMs, or they can also come out from databases and caches. So it's kind of a comprehensive look of the system itself. So you may be wondering, or since you already heard of the term observability, why it is important. So I want to take you back for a second to about 15 years ago, perhaps, I'm roughly, and we'll think about monolithic architectures. And if you were pinged at the middle of the night at that point, in a monolithic architecture, you could just tail a log file, for example, and then kind of quickly figure out what was happening in your system. Moving forward to when microservices gained a huge traction, you can imagine when you have 10, 15, actually essentially more than 5 microservices, figuring out what happened is like looking for a needle in a haystack. Like you can't actually know what happened. So as kind of an opposite of monitoring, Faiz touched on this a little bit before, is monitoring kind of just tells you that something happened, whereas observability tells you what happened and perhaps where it happened. So this kind of just allows you to go through this cycle once you have observability in place, is to go through a detection phase. Perhaps somebody, at the most basic level, your customer is going to call you up and raise a ticket saying something's gone wrong. But hopefully, if you apply observability, then you'll be able to detect it through automation. Using all of the signals that come out of it, you should be able to investigate it, know exactly what happened, where it happened, and finally provide remediation. You provide a patch, and you push that patch out to production. So at a high level, organizations get a comprehensive view of the entire system if observability is done well. And we'll look at how you can implement it in just a second. This may seem a little meta at this point. So observability really defines 3 pillars amongst which it is measured or tracked. And they're metrics, logs, and traces. Metrics are quantitative points of data. So you can think of CPU usage, RAM usage, disk usage, network usage. And the reason, of course, is it's useful is because it again provides a high-level view. You can see that on the graph there, is that you have this Prometheus dashboard, if you've heard of Prometheus, where you have the state of the system, your CPUs and RAM and all that, and gives you a good high-level perspective of what's happening. Logs, I think every developer, like 101 is logs. They are They are points of data, they're events, they're usually structured, and they usually have timestamps. There are things that allow you to debug the system more easily when the time comes. Traces, if you've not heard, and this specifically is distributed tracing. Traces are a way, in my mind at least, they're more user facing. They allow you to like capture the flow of a request through your entire system. So let's take a fintech kind of example, like uh, for a moment. If you imagine that the user presses a button to make a transaction, that request goes off to potentially more than a handful of microservices, event-based systems, databases, caches, etc. So traces allow you to actually visualize that request all the way through until it comes back to the user. You may be wondering why traces are more, or why they even exist if we have logs. Well, you may be right in thinking so. Logs are a form of tracing, but they're more manual. But on top of logging, tracing and tracing libraries allow you to add context to what's happening. So if you were to think about it, let's say you made a request to a database. While a log may say, made request to database, got response from database, a trace would actually show you the latency that it took for actually making that round trip, and a bunch of other meta properties that you can add to a trace, which we'll look at in the demo. So with those kind of three pillars in mind, what is open telemetry? Because we've had observability for a very long time. It's not a novel concept, but open telemetry is. So open telemetry is a CNCF project, Cloud Native Compute Foundation project. It's not like an infrastructure component. It is a specification, and it specifies and standardizes the generation, collection, and export of those three telemetry signals that we saw, which is metrics, logs, and traces. So in order for it, like for us to implement this specification, they actually expose, much like how all of us do in our APIs, they provide APIs, they have SDKs around those APIs, and they provide a bunch of tools that help with stuff like infrastructure collection of those signals. So I don't know how clear this is, but you can see OpenTelemetry right up there. I'll zoom in on this in just a second, but this graph shows along the x-axis, it shows the commits for the project, and along the y-axis shows a summation of PRs and issues. Kind of showing you this to show you that it's a serious project that's actually being adopted by fairly large tech companies. You can also see on the right-hand side, just for quick reference, the kind of ranking it has by different matrices. All right, so all of this is fair and good, like it's, yeah, but why do we need it? We have Prometheus, we have Jaeger, we have X-Ray, we have a whole bunch of things that already do this. So why do we need a standardization layer? The problem kind of comes in because with too much choice, I think comes a lot of pain. If you just had one way of doing things, the whole world would be happy in a sense. But if you're spoiled for choice, then we also have more processes in place, more training and setup costs, and there's also vendor lock-in. So open telemetry allows us to consolidate all of these things into a unified interface, much like how UPI did for payments. So if there's just too many ways of doing the same thing, and I mentioned there's vendor lock-in. So for example, let's say your dev team has implemented Prometheus for metrics, Jaeger for tracing, and any number of Fluentd for logging, let's say. But the cost for this is too much. Your organization says we need to minimize cost, which is the case with most of us nowadays. We need to come up with a way to reduce this. So let's, imagine you had like 10 different or 15 different microservices, all kind of implementing these different protocols. It's going to be hard for you to go in there, change the tooling to instrument the application, collect those metrics, and push those out into Prometheus. So that's a very hard step to do. So the way OpenTelemetry addresses this again through standardization is by doing three things, and we'll look at the architecture here. So the way it does it, first of all, is through SDKs and APIs. So you'll see on the left-hand side of this diagram here that you have something called auto instrumentation. And instrumentation, like hand waving this thing, is just by saying, you have something to measure, we're going to put an instrument on it so we can measure it. Like how you have a speedometer for an engine, you have instrumentation for your Kubernetes pods, application, it may be anything. OTel API and SDKs are kind of just things that implement that instrumentation. So also on the left-hand side, you will see there's instrumentation for shared infrastructure. So this can be, like it says, proxies, Kubernetes, VM, it can be anything. On the right-hand side, is your telemetry backend. And by this, I don't mean API backends. I mean telemetry backends like Jaeger, like AWS X-Ray, CloudWatch, Prometheus. These are all your telemetry backends. And in the middle is kind of this workhorse component. And this is actually something that is a deployable component in OpenTelemetry. This is a thing that you actually can write Helm charts for or manually put out a Docker image for. And this takes everything from the left-hand side, combines it, and puts it into the right-hand side. We'll look at this in the demo of how it is. It's basically a YAML file that you can configure, and it's super declarative. It's very nice. So on to the demo. So putting all of that stuff into context, for the purposes of our demo, I've spun up three services. They don't actually do much, but there is called the product service, the user service, and the auth service, your typical microservice architecture. In the middle is the hotel collector. I'll show you the configuration for that, which has been configured to push everything to a local running Prometheus. Grafana has a few offerings. So Grafana Loki for logs and Grafana Tempo for tracing. So I'll quickly bring up my screen here. Well, I think the specifics of this code is not too important, but I think we all like writing code. So I will show it here. There's also actually another window here that I need. Okay. This is a typical kind of Node.js application. You have the user service, the product service, and the auth service. They're not really doing anything too fancy. A couple of things to note here, though. I'm going to like zoom into the product service, and all of the other services follow a similar pattern. So I'll just focus on this one for the sake of this presentation. There's this little library that I wrote to consolidate the implementation. This just goes too deep into the weeds for me to show you, but this is essentially an abstraction to make working with telemetry with JavaScript very easy. And so you can see here that I'm giving it a service name to kind of identify what the resource that I'm actually tracking. I mentioned the collector component earlier. So the collector component, like I said, is a deployable artifact, and it actually exposes some ports. So it's available for me because I'm running it locally. It's available on localhost, and that's the port. I won't go into the documentation again. This is all very well documented at OpenTelemetry.io. And a few other things, there's some instrumentation, right? If you remember, if we briefly touched upon the auto instrumentation stuff. So this is what it looks like when you manifest it in code, is that there are open source libraries that actually do this auto instrumentation for you. Fastify, for example, auto instruments everything HTTP. So it takes a look at your middleware and all of the stuff that goes into Fastify specific stuff. It actually takes care of that for you. We will look at, just to show you contrast to auto instrumentation for this, you see here that the user service is actually using MongoDB, and you can actually auto instrument MongoDB itself. And we'll see why this is useful in just a second, but the fact that everything's doable with just a couple of lines of code is actually quite magical. That out of the way, I'm very excited to show you the collector configuration itself. So the collector at a very high level has three components. It's got receivers, processors, and exporters. And kind of go back a second to that slide that I showed you. On the left-hand side, you have things that are receiving, coming in. On the right-hand side, you have things that are going out. And the collector kind of sits in between. And that's what's happening here. So the receiver is the left-hand side of that equation. It takes all of the inputs from in different formats. So if you look at the receivers here, I have set it up so that it takes, well, this is the network protocol, gRPC. It's not using HTTP, but it's using the OTLP wire format. And then the OpenTelemetry specification, because it's a standardization, comes up with a wire format for OpenTelemetry itself. Like this, you can see below that I've actually commented it out, but it also takes a file log. So for example, if you're running a bunch of apps and you're logging everything to a local file system, it can actually read that. You can have an agent on the VM. It can read stuff from that file log and push it into the collector if you'd like. It also takes a bunch of other things. Going back to standardization, say your team already implemented Prometheus. if you want to move slowly to open telemetry, as you can imagine, moving infrastructure, observability infrastructure, in a lift and shift kind of method is not possible. So say you have Prometheus kind of pushing out metrics, you can have a Prometheus receiver here and just have the collector then start collecting those records and then pushing them out as a first step. But you have a whole bunch of receivers here. Processors are a thing that happen within the collector itself. So this is stuff where you can add metadata to the collector. You can add some kind of timing function. So you can say, I want to like buffer up certain bytes of data before I push it on to my backend, because you don't want to overwhelm the backend. You can imagine every backend also has its own rate limits, and perhaps comes with it some network traffic. If you're in AWS, you know the huge cost of network egress in AWS, and also comes with it, so the rate limit itself. So you can buffer those things, and if you want to add metadata to the final record that ends up in your telemetry backend, you can do that here. Again, I will point you to the documentation for the specifics. And then finally, we have exporters, I think, which is like the really exciting part of this, is the right-hand side of that equation. Is here you can see that I'm pushing all metrics to Prometheus. I'm pushing all traces to actually speaking OTLP HTTP, which is the protocol Tempo speaks, and localhost. But you will see that here I've referenced Tempo's coordinates. But how does this all come together? Like, just giving these key value pairs is not magical. You just have to put them together, and that's where this service pipeline comes in. So you're going to say, for all of my logs, take it in through the OTLP receiver, process it with these processes, and then push it out to Loki. Similarly, for traces, take it into OCP, OTLP, push it out to OTLP. Similar with Prometheus. So what does that look like once we have done all of this stuff? So before the talk, I actually went ahead and accumulated some metrics, so we don't have to wait here and twiddle our thumbs while all of this stuff comes in. But quickly, I will give you an overview of what's happening. The first three tabs on top are the services: the product service, the user service, and the auth service. The one here is the logs from the collector itself. So you will see here, I've put a debug kind of within the collector. So you can see as kind of things get buffered into the collector itself, they're being recorded here. I have some sort of script running so that we can have requests going on in the background and I don't have to do them manually. So with all of that out of the way, I'd like to show you the output of all of this not so hard work. Firstly, I think, let me start off with dashboards. This is Grafana, if you're not familiar. And Grafana allows us to work with a few different backends. And here I mean observability backends. If I do this really quick, you will see a huge list of backends that you can add. It works very well with most cloud vendors. It also works very well with self-hosted stuff. So I'm using local Loki and Prometheus. And so here I'm going to zoom out here just a bit, just to show you what we're looking at. So I've crafted some very simple queries. You can imagine, stretch your imagination and see you can put more queries on top of this. But the green line in the first panel there gives you the total requests of all time. The red line gives you the total number of 5x's of all time. And that is per route. The legend below is the status code. The average request latency per route is also here. And you might not be able to see it, but that's a slash because I only have one route and this is for the user service. So that's giving you the average latency. Below are a few gauges where it tells you the number of errors. We may want to alert on this. Like going back to what Faiz said, it's very important to have this monitoring and alerting stuff going on so that you can quickly respond to them. So this, you can imagine you have this number, you can put an alert on it and get it through Datadog, SMS, Slack, whatever it may be. And then here we have the 95th percentile of request. I think we're doing pretty good. That's 23 milliseconds. And the same thing for product service. Product service is a little higher. The reason is that kind of, to draw a mental model, the input to the system is the product service, not the user service or the auth service. So this is cumulative latency from all of the requests made to microservices. So this is metrics, and Prometheus provides a great way of tracking, querying, and Grafana gives us a great way of looking at them. What I'd like to draw your attention to now is, I got excited with this. It's tracing. So let's just do a search and you'll see a bunch of things here, and these are all traces. These are requests. Each one of these represent a single request to our system and the service that is actually accepting that request. One thing that I'd like to point out before I go forward is there is a tab here. There is a Service Explorer tab here, which actually draws out the service for you. And I'll show that to you in a second. So here, if we dive into, let's say, a request that took a really long time. This one took 77 milliseconds. That seems a little odd, and that went to product service. So let's actually go look at that. And you'll see that it opens up side by side to the UI itself. Now, this will obviously work with every other tracing backend, Jaeger, AWS X-Ray, all of that stuff. This is all locals. I've just kept it in tempo. This is what I mean by looking at the request flow right from when it starts. You can see that it started off at the product service. It did the DNS lookup. This is through auto instrumentation. It went to the user service. User service actually went to MongoDB. And so you have a level of granularity that is very hard to get with just logs or with just metrics. So this kind of traceability allows you to get to the point of either where you need to optimize on performance. So say, for example, there was a slow running MongoDB query. You can actually see that here. It's very visually represented. Or if there was an error, which we'll check in just a second, you can actually see where the error happened. So just looking here, I mentioned briefly at the beginning that there is something called span attributes. And these are things that you can add to the span itself to add context to what's happening. And this goes back to kind of the philosophy of observability, is that it's not just about something happened, it's about what exactly happened and where it happened. So adding context really helps. So you can see here that there's a query here. Of course, there should be PII in place and all of that stuff. You need to do that. But the ability to add this kind of stuff is supremely important. Finally, I think what I'd like to show you is, yeah, Loki is just logs, and I'll just filter by product service. This is boring old logs. I think we're all pretty used to this. There's nothing special here. But what I'd like to call out is, let me filter out not just service, but something interesting, which is the errors. So let's go really far back. Right. So we have a bunch of errors, and this is kind of orchestrated by me on purpose just to prove a point. So let's look at this error, and because of the auto instrumentation, every log line has something called a trace ID and a span ID. This goes into distributed tracing. If you actually configure things correctly a little more, you can actually have a button here that opens up tempo on the right-hand side. But I'll do that manually for now. Opening up tempo, I'll place that trace ID here, and you can see here that there was an error in the product service, and we can dive down. You can imagine you can dive down into exactly where that error happened very quickly. So there's no tailing of log lines. There's no stitching together of correlation IDs between a few different services. You just come here, you see where it happened. You think you have a hypothesis that product service has an issue. You come here, you filter, and then you debug. Therefore, it kind of helps with your debugging cycle. I was zoomed in before, but I just wanted to touch upon this service graph. I haven't been able to set this up yet for the demo, but you can imagine here that you have product service, auth service, and user service. Here you would actually see that graph, and you would see kind of requests going through, average latency between those services, etc. You would also see MongoDB in this service graph. So that's about it for my demo. I do want to touch upon, I think, the most important aspect of this, which is why you should care. Why should a DevOps person care about all of this stuff? We went through this in the code, so that's just the library doing its thing. So why would DevOps care? Well, for the first thing, capacity planning. And this is actually something that comes out of a case study for me that I implemented for one of my clients. If you have all of these metrics and all of these data points coming in, and you have them historically, let's say for 6 months, 1 year, you are in a better ability to say, of all of my clients who are here, I can actually kind of predict that I need X amount of CPUs, Y amount of RAM, and then provision accordingly. So for one of my clients, they had a multi-tenanted system. And multi-tenancy can mean a lot of things, but in this case, it was having separate kind of VPCs for each client or cluster of clients. And in order to correctly know how much to provision for those clients, this data came in very handy. So capacity planning is a huge win for putting in observability. Second, availability. I think this is what everybody's gunning for, especially you wonderful folks in DevOps. If you are able to detect errors or latencies early on, um, you're very easily able to get better MTTR and therefore reduce downtime. So if your errors are very high, if you put an alert on it, your mean time to recovery is going to be very high. If your mean time to recovery is going to be very high, your availability is going to be very high. Going forward, you can have preemptive analytics in place. So if you, even just statistically, we don't even have to do AI and ML, although that is really nice to do. You can have statistical probabilities to preemptively catch something. So if you can see that during, let's say, a flash sale of Flipkart, they had good monitoring and availability, you could say every time my Black Friday sale or whatever it's called comes over, I know for a fact I need to provision this much. So I can preemptively kind of pre-plan this infrastructure. Finally, we have anomaly detection. Given enough kind of given enough historical data about what's happening, given enough metrics coming through your system, you can actually put in alerts in place, put in statistical AI models in place to detect anomalies. And these anomalies could be somebody trying to DDoS you, for example. It's like 12 in the morning, you typically don't have any traffic, but suddenly you have a spike in traffic, your CP is off the charts. You can have alerts in place to do that. Network issues, security issues, these all can be kind of detected fairly early on in the cycle, and you can mitigate these security threats. And so there are a bunch of other obvious use cases, I think, but I think these stood out to me as very high-level touch points of why observability really helps. So I thank you very much for taking the time to listen to me.